I'm from Melbourne in Australia, and I've travelled all the way to Pasadena for the first time, so I'm pretty excited to be here. I'm a developer advocate at BuildKite. If you haven't already talked to us at our booth, I'll quickly give you the spiel because they paid for me to get here, which is very kind. We're a super flexible and super powerful CICD platform. Some of the biggest and best teams in our industry use us to ship their software. We have a unique hybrid model, which basically means you run our build agents on your own infrastructure inside your own environment, on any cloud, on physical hardware, whatever, and we host and maintain APIs and a UI for you to look at your builds and interact with it and all that stuff. So that's enough of that. Let's get into it. Why are we here today? Well, you've probably read what the talk is about, otherwise you wouldn't be in the room. We're here to look at CICD through an SRE lens. We'll cover some of the issues we might face in CICD, and we'll take a look at some SRE principles that we might apply to chip away at some of the problems. Now, today's story is going to unfold in 3 parts. Like every good narrative, there'll be a bit of a story arc in there. I'm not saying it's going to be a great story, but there will be a story arc. So let's get into it. If there's no drama, we're not shipping software, right? Like it's part of the game. So let's just set the scene. We have a monolithic code base. We have a gargantuan test suite. And for some additional drama, we have microservices that stretch for as far as the eye can see. And that's the software landscape that we're building our... Yeah? Sure. I've got to play a kazoo in a minute, and I don't want it to get in the way. But that's the software landscape we work in. It's very, very complex. There's a lot going on, and it's pretty difficult to navigate. But look, I'll let you in on a little secret. My talk, like I said, is shorter than the allocated time, so we have some time for some music. And we're in LA. It's all about movies. And we know a musical score helps people feel things. And I want you to all feel the pain of like the story that I'm about to tell you. So I've got a kazoo. It's not a pipe, as some of my colleagues thought that I came prepared from Melbourne with. So let's just give this a shot. I'm going to play some music. See if you know what the score is. Okay, well you knew what the score was, right? It's such a cool... I implore you, it was like $10, best money ever spent. Anyway, sorry, I've inflicted this on my workmates before and I had to do it in front of everyone, so thanks for bearing with me. Now, I don't know about you, but I love challenge. I'm guessing that's why, you do what you do. Like the talk earlier today, we like debugging, we like problems, we like getting into that complexity and we like untangling it. It's a blessing and a curse, but it's a challenge we love to tackle. And no problems today. Today's going to be great. It's a big day because my current epic challenge it's coming to an end. I'm finally shipping a thing that I've been working on for months now. My branch is green. Let's go. What are we waiting for? Engage. It feels good. My build's kicked off. It's time to sit back and chill for a bit before I pick up my next story. And I love it when a plan comes together. But my build's failed. Why? Why? Sifting through the logs a little further, I can see that a test has failed. And I'm blocked. And down I go, down a rabbit hole. A rabbit hole I don't like going down, but I'm going down there. So I don't know how you feel about CICD. I love CICD. I mean, I work for someone who builds CICD, but I love it more as a software engineer when it's not getting in my way. As a software engineer myself, I prefer it when I don't notice CICD exists. Like, I want it to stay over there and do its thing, and I'll stay over here and do my thing. I'd like to push my code. I'd like to know my code is tested and that it's safe, and I'd like it in production within minutes, even on a Saturday evening. Is that too much to ask? Apparently it is. And we end up not fully trusting our CICD, and we end up battling the system, and we end up adapting workarounds to processes that just don't live up to what they're supposed to. And like it says on the label, continuous integration and continuous deployment is the automation of building and testing code. CICD allows teams to ship code easily and frequently with a high level of trust that end users won't be impacted by bugs. But that's not what it feels like right now for me. At least in BuildKite, we get a retry failed step button, which is good because at least I don't have to kick off my entire build again and wait for it all to go through every step and see if it fails again. But I'm mashing that button, and that same test keeps failing and failing and failing over and over again. And I don't know what's happening, but I only want my changes to be merged. And it turns out flaky tests are a thing. I know that because there are literally thousands of memes out there. When I typed into Google flaky test memes, I was staggered. There was 8,000 results or something, and I'm like, so what we do when we get blocked by a flaky test is not try and fix it or solve the problem. We go create a meme. I mean, you got to do what you got to do, right? But flaky tests happen for a lot of different reasons. Sometimes mostly it's time and time zone related, but it could be integration specs not finding an element. It could be just a test ordering thing. There are a ton of different reasons why they happen, but no matter the reason, they're very annoying and they're very baffling. And this is a real life story. I remember when I had my first dev job. So I'm fresh, pairing with a senior, what could go wrong? But there was this smoke test that used to fail all the time. I don't think I'd ever seen it green. And so I'm sitting there and I'm like, well, I've got my audience who's a senior. He needs to know the answer, surely. And I turned to him and I said, why does this test not pass? And he's like, oh, that's never passed. And I'm like, maybe I'm a junior. Maybe there's something that he knows that I don't. But I was like, why do we run it then? Why is it still there? And then from that moment on, every time I got a test failure, I'd be like, it's not my code. It's not my code. It must be a flaky test. Is it a real failure? Surely not. There's nothing wrong with my code, never. But thinking about that, it's as a software engineer, you need to be able to rely on CICD, and you need to be able to trust that the results that you're seeing and getting are factual and real and trustworthy. CICD needs to provide us with fast, reliable feedback about the software delivering, and when we don't, we've got problems, and so do our end users, because you end up, bypassing things or not fully trusting CICD, even when those failures are legit. And developers need to be able to trust and rely on the tools that they use to get the job done. End of story. Now, because I like rabbit holes, I went down one, and I was like, can someone pull me some figures on the impact of, well, we're guessing they're flaky tests, but it's hitting the retry button when a step fails, right? And then if it ends up going green after they've hit retry within a matter of seconds, chances are they're flaky tests. And I was pretty staggered to see these numbers. That is a very real monetary cost to retrying tests. That's someone sitting there waiting and retrying. They're big numbers. And this is just BuildKite users, which, as we know, there's lots of other CI/CD tools out there. So think about all these users dealing with flaky tests. BuildKite users spent a cumulative 9,413 days over a 1 month period. And over 1 day, it's 59 days. So that's pretty big. And to use a Martian for scale, you can get to Mars and back 17 times in 9,413 days. That's just BuildKite users. That's a lot of time. And I think in the current financial state we find ourselves in tech, you don't want to be wasting time like that, I don't think. And besides the time we all spend hitting retry, we've lost our flow. And I don't know if you're anything like me, but as soon as I step out of my code editor or terminal, if there's another window or a tab, I'm in there I'm like looking at Slack, I'm like scrolling on Twitter to the end of the earth, you know, what's going on? Not much really. But it takes time to get back into the zone, and that is the flow that we don't want to be lost, really. So I probably don't need to go on, you get the picture. I'm sure you've been in the situation that I am in right now. But let's look at how to get out of the funk. How can we reduce the impact of situations like this? So, turns out SREs know a thing or two about ensuring our systems are reliable. There's a clue in the name there. Just a quick history lesson. You probably all know this, but just because I liked diving into where did this come from. The first SRE team was formed at Google in 2003. They wrote a very famous book about it called Site Reliability Engineering and How Google Runs Production Systems. Did you know this is not a monitor on the cover of this book? It's a lizard. Why would you write a book about SRE and not have a monitor on the cover? I can't get an answer out of anyone about it, but it's baffling. But anyway, O'Reilly. But we can't talk about SRE without first talking about DevOps. In that book, DevOps is defined as a loose set of practices, guidelines, and culture designed to break down silos in software engineering. What is it? I can't read there. Operations, networking, and security, and that's it in a nutshell. DevOps principles encourages us to remove silos, do away with any barriers that exist, either organizational or between different disciplines. To understand that accidents are a normal part of building and maintaining software. And it also encourages us to embrace gradual change, which, as we know, CICD plays a big part in that. And also to understand that tooling and culture are interrelated. And so whilst we love tooling and automation and they're super important, DevOps thinking understands that the human systems and processes and the culture of the organization is far more important than tooling and automation, and far more critical to being able to adapt to change and things like that. So I like that one. And finally, they say that DevOps thinking understands that measurement is crucial for success, and that is crucial to the success of everything, to breaking down silos, to managing production incidents, and that it's essential to be able to clearly and objectively measure and verify reality. So, DevOps is a philosophy that's alive and kicking, in case you were wondering. It's also a way of thinking about our work, about our people, and about our organizations as an ecosystem that needs love and nurturing and care to keep it working and healthy. Whereas SRE, on the other hand, is a bit more practical. It's about improving operational practices, efficiency, and as the name suggests, the reliability of our core systems. And that sounds good to me, because I don't know about you, but I like CICD being reliable, because it kills me when it's not. Now, there's many examples of SRE principles out there. There's no catch-all definitive list, but there are some common characteristics included in any different definition, and that's the automation or elimination of anything repetitive, especially when it's going to reduce costs. That there is system design with a bias towards reduction of risks to availability, latency, and efficiency. And that we should have the ability to ask arbitrary questions about our system without needing to know ahead of time what we'd like to ask. We need observability into the state of our systems and our system health. And this is my favorite, that we should avoid more reliability than what is strictly necessary. And I really love this principle. I used to think I was lazy, but it actually turns out I was on point. SRE focuses on reliable services, but 100% reliability is never the goal because it's unattainable, as we know, and we all accept that mistakes are a part of delivering software. And if you're in the room and you don't make mistakes, you're either lying and covering up really well, or you're sending your company broke by like taking too long to ship software. So yes, I'd be keen to hear if you have never made a mistake or have shipped anything dodgy. I certainly can't claim that. But perfection is unattainable, which is why CICD is also so important, because it's a safety net. So, I got to get back to shipping this feature that's been blocked. I feel really not in a great place. Mercury isn't in retrograde, not that. But if I'm honest, we've had problems with our CICD for a while, and these problems keep cropping up when we least want them to. So how do we address the problems? Well, we just heard about SRE, so let's look at putting some of those principles into practice. So things feel really bad. They feel really bad. We know we have a problem with flaky tests. We're pretty sad about how slow our builds are, how long we even need to wait for a build to kick off. We know it feels really bad, but what do we actually know? Remember, DevOps thinking and SRE both say that measurement is crucial for success and that we need observability and to have ready access to information about our systems. We need to measure the health of all our systems. We need solid metrics as an objective foundation for the conversations with our teammates, with our leaders, and we need to be able to agree that they're an accurate picture of reality. And if we rely on this data to illustrate the monetary cost of what the pain actually translates into, it's no longer about feels or how we feel about systems. It's based on data, hard data. And that can drive the maintenance of these systems. Because if you're like in feature delivery, the hardest thing of all is to be able to prioritize and justify maintenance of systems. It's like the problem all software engineers everywhere have to struggle with. So stay with me. How does it work in practice? Let's take a look. I love this quote, and similar to it being impossible to do your job well without clearly defining what well means, how do you improve things if you don't know how bad things are to start with? So site reliability engineering uses SLOs, SLIs, and error budgets to explicitly document expectations around what well means for them and for users of the system. They use them to define what's important and how reliable things should be, so that level of reliability that we're aiming for, and they use them to measure how performance is tracking towards that goal. So an SLI is a key metric used to indicate whether an SLO is being met. These are the metrics that you will use to actually keep track of how well things are doing. And an SLO is literally a promise or a commitment that's made in relation to something that matters to users or maintainers of a system. Like, here's what I know you need from this system, and we will make sure that happens for you. Or I hereby commit to keeping you happy, but only this level of happy and no more than that. Which is a fair statement to make if you're practicing SRE. And where an SLO defines what level of reliability users would expect, the error budget defines how much or for how long that service can fail to meet the SLO without any consequences. I guess you're going to ask how do we get people on board with adopting these practices? But I'm guessing if you're thinking this sounds like it might be a good idea to try, you're probably feeling a bit of pain, which also means other people are feeling the pain too. And enough is going down in our teams and our companies at the moment. We need some bonding time. I think this is the perfect time to come together and start chipping away at, some problems and starting to work to improve things. No more gut feel, no more being reactive and shifting focus when things are blocking you. We have a framework that we can use to solve that, and we're going to assign metrics and we're going to strive to uphold them, but only when we need to. So now it's time to ask some questions about your system. In my case, it's CICD. Get everyone in the room together with a whiteboard, start building that shared understanding. What is the system in question? Is it your CICD? Are you going to limit the scope to an application's test suite? Is it its speed? Is it its reliability? Who are all the stakeholders of this system? Are they in the room? Because they probably should be. Who relies on the system, who uses it, maintains it, what's important to everyone, what's working, what isn't working, and what needs to be better. And I guess the quest of this exercise is to understand, to share, to come together and build a collective understanding of what everyone expects from the system in question. And once you have the shared understanding, it's time to agree on some SLOs, SLIs, and reasonable error budgets. I'd recommend starting with no more than 3. 1 is good. 1 is a good place to start. And let's look at a few examples that you could try. You might want to stop developers waiting around for builds to kick off. You might set an SLI that is total wait time for builds to start, and you might commit to builds should start running within 30 seconds. And again, your error budget will have so many builds that take more than whatever thing you agree to start running, and there'd be a 4-week period for that error budget, for example. And a side note, there's in the SRE book, there's a method to calculate your error budget, which is 1 minus your SLO percentage. You can just Google how to set an error budget. There is a million blog posts about it. But there'll always be a time frame and a value that you commit to. You might commit to developers having commits tested and notified of success or failure in 5 minutes. Your SLI would be total build time, and your error budget again would have X many builds that finish in more than 5 minutes in a 4-week period, for example. And this is a good one for me and my problem today. This SLO could be that the test suite should have a reliability score of greater than 87%. And here your SLI would be the test suite's reliability score. Again, an error budget with a bucket of amount of runs with a score of under 87% in a certain period of time. So how do you get the metrics? We've probably all heard most of these names, but obviously, when it comes to monitoring production systems, an infrastructure, Datadog and Honeycomb are the big players. Honeycomb even has a product specifically for managing SLOs along with their observability tooling. There are many, many services that will allow you to configure custom metrics. For total wait time SLI, BuildKite, I'm going to talk about BuildKite because obviously this is the CICD tool that I use, but it's just an example. BuildKite has a CLI tool for collecting agent metrics, which are things like build runtime, time for an agent to spin up, latency, all those things. We also have open telemetry instrumentation, so you can send traces and metrics to all those tools that have collectors for OpenTel, Honeycomb, Splunk, Lightstep, etc. If you don't use BuildKite, it's fine. Your CI/CD should also have these metrics. And Datadog also has a CI visibility tool that you can use. I think it's been around for a couple of years, so you could also look at that. I don't know why I put Honeycomb in there. Honeycomb, yes. If you want developers to have speedy feedback loops, your SLI for this would be total build wait time. BuildKite has a REST and GraphQL API endpoints to get this data. And in our UI, there's also a monthly average build time that's visible for each pipeline. But again, your CI/CD would probably have this kind of data as well. And once you're measuring this build runtime metric, you can start tuning your CI infrastructure and pipelines as you need to, but only when you've spent that error budget, of course. So because BuildKite agents are hosted on your own infrastructure, you can leverage the same cloud-hosted auto-scaling compute capabilities as you would for your production infrastructure. I basically just wanted to do this because it's too cute. And your pipeline steps can also be optimized to run in parallel across as many agents as you need to really speed up your builds. Actually, this is what test splitting actually looks like, but imagine if it was the cat. It'd be so good. Actually, the person whose cat that is saw me tweet this picture and they're like, that's my cat. And I was like, that's so cool. Yes, but we have an Elastic Stack, which is basically a CloudFormation, yes, template that within a few clicks you can get an auto-scaling agent environment in ECR in your environment, working to run builds across as many agents as you need, thousands if you need to. But again, this work only happens if you've exceeded your error budget because you've broken that promise to users of your system. And speeding up builds isn't just about optimizing build agents or scaling your infrastructure. It's also important to consider the performance of your test suites. So BuildKite has a tool called Test Analytics. You don't need to use BuildKite for your CI to use this tool. You can use it with GitHub Actions, Circle CI, or Jenkins. It works with any CICD, and you can use it for free for a certain number of test runs. So I encourage you to look at that if you want some insights into your tests. You can track down the slowest tests and then identify some really quick speed gains for your builds that way. In this example, you can see a single test that formerly took, this is a single test, mind you, that took 35 seconds to run, and it now runs in under 3 seconds just by switching out a capybara matcher to a different one. So that's a 32-second speed increase, decrease, whatever, gain, trimmed from a single test. And if you imagine that across an entire suite, that is huge. So again, once you've defined what's important, what your users should expect, and you get access to those metrics to monitor this SLO, you can ignore it until you've exceeded the level and spent your error budget, but then you can get some of those winning feels. So as I said, there's numerous ways to bring down your build times. I've already mentioned auto-scaling and comparing, ensuring that your steps are split across parallel runs, but you can also build dynamic pipelines, which is something BuildKite allows you to do, which is to generate your pipelines at runtime rather than in a static config file. So that means you could just run builds that need to happen based on anything you want, really. It's logic. So like, did something change? Don't run that step. I'm deploying to this environment, don't run those steps. So that's another speed gain. And lastly, this is a really cool example. Actually, last time I did this talk, someone's like, give me an example, a real one. This user started tracking via an SLI their total job minutes, and like by prioritizing those and bringing those down through some of those things that I've already mentioned, they managed to save 1.8 hours of job minutes per engineer across 2,600 engineers, which is a saving of 10 years per month in job minutes, which I think is pretty amazing. That's a pretty good, well, it's good for the environment as well, if you think about like the computation cost and the energy cost and all the things, besides the waiting around. So data and insights, they're the bomb. The problem that blocked me today was also test related. The SLI that I set for this SLO is Test Suite Reliability Score. And you can get that score in Test Analytics. Again, you can see that it's pretty low. It's sitting at 77.26%. And that means that before too long, I'm going to chip away at the error budget and I have to get in there and fix it. There it is. I thought that's supposed to be a GIF. Yeah, you can see like the reliability percentage over time, and if it's hovering, and as you can see, it's pretty high, so I'm going to have to do some work. We also have a flaky test tracker that's currently in private beta in that tool, which again you can all use for free and without being a BuildKite user. It's currently in private beta, but in a couple of weeks it will be in public beta, and it's a list of 100% definitively flaky tests. So if you decide to try Test Analytics, it might be handy, but there are other open source tools that do similar things, and I know that if you use Bazel, they have a flaky test scoreboard tool as well. So many options for finding your flaky tests. But it's all great to have these insights and this data, but if you don't prioritize the work, there's kind of no real point to having the data available. It's like any tool or any automation, it's only as good as the human systems and processes around it. So once you have the metrics, you have the visibility, the observability, now you have the solid foundation for having conversations with people about prioritizing that work, and that's pretty great. So it's horrifying and it's amazing that we have the data. It's horrifying because we now know how bad things actually are. Maybe they're not that bad. but they are in my example. And it's amazing because we are in a position then to like start improving it and start bringing that number down. Turns out the test that failed for me earlier was a flaky, and now that I know that it's a flaky 100%, I can quarantine it, get my feature out, so that's good news. But yes, getting to prioritize this work and using these insights, that is actually the hardest part, and like I said, that's where error budgets come in. They're a gift to focus. You basically spend, and when you're within budget, it means you don't have to drop everything and be distracted by, going down that rabbit hole. It means you can quarantine the thing if it's a test and just move on. You ignore it until you're out of an error budget, so no more rabbit holes. They exist so we can maintain momentum and focus. But once the error budget's gone, I've seen this actually, that's when you have to like broker an agreement with everybody about what happens next. So I think we can be real together. This feels like a safe space. The concept of downing tools to fix a system once the error budget isn't met is a huge point of contention. I've seen product managers really struggle with this and other people. It is the hardest thing of all when implementing this framework and way of working. But at least if you had the discussion and you've all been in the room, you've all agreed on what is considered important. You all have the metrics as a solid foundation for discussion. So it's not about feels. It's not about how someone feels about a thing. It's like, this is the performance, but you all agreed that this was important to us and our users. And now it's about negotiation and discussion. It's important to remember that SLOs, SLIs, and error budgets, they're a journey. They're maybe dragons, but there's iteration. Iteration is always possible. Change is always a good thing. They're not written on stone tablets. Start out small. I recommend, like, if you haven't got this process in place, you could start with an SLO that is currently, I'm collecting the metrics now. I know what we're currently sitting at. Perhaps I'll set an SLO that is what the current state of the system is performing at or whatever. So you could start small and at least you have the data then. But there's massive gains to be won, even if it is just being able to focus on the work that you're currently doing instead of being distracted by all the things going wrong around you. But let's just take a moment to imagine this new world. You'll iteratively manage the growing complexity of a system. You'll be able to prioritize maintenance and upkeep. You'll be happier. You'll have happier developers with clear goals. Everybody loves goals. Everybody loves tracking goals. You'll be saving time and money. And more importantly, you will have restored trust in CICD. You'll ship less bugs and you'll protect your customer experience. And I'll leave you with this always amazing, Charity Majors always comes out with the good statements. I'll leave you with this quote. There's a lot in there. But SLOs are a powerful weapon to wield against micromanagers, meddlers, and feature-hungry PMs. They are an API for your engineering team. That's all, folks. I hope this sparked some ideas for you that you could take back to work on Monday if you're not having your weekend off. Come and visit us at our booth tomorrow and say hi. I'll be there. I've got Aussie treats with Vegemite in them, if you're brave. Here's some Twitter details if you still do Twitter. I'm also on Mastodon. And yeah, come and say hi. Thank you. Thanks for sticking around till 6:35. That's like pretty epic. Cool. Anything? Yeah. I'm okay with comments too.
Well, first of all, thank you. This was all very nice. So combining very serious things with these things that make us smile.
You.
What about we focused on the tests and so on, which were maybe on the CI side more. What about the CD side? What could you say about that?
Yeah, I'm not really sure. I guess, no, I don't have an answer, sorry.
Is there something more specific, so we define the tests here and like the runtime, and these are like very useful examples if we are going to implement as a starting point for us. But
What issues?
what would
yeah.
be like the SLIs in the case of CD?
That's a
pipeline?
whole nother ball game, isn't it?
Okay.
Like, yeah, do you use, how do you,
We use Jenkins still, and we are moving to GitLab soon.
yeah.
That's all.
I mean, how do you manage your deployments?
Our
Is it-
deployments, it depends on which service it is. Some of the services are like kind of more continuous, and some of the services have more direct, like where the business feels that the impact would be bigger. They go through a process, which is an approval process and so on with a
I
gate.
see. But that's okay. I mean, yeah. I don't know how you would make that more reliable or less reliable, but I mean, that's time spent waiting, isn't it? It's the approval process, right?
No, I was just thinking if there is something like more specific to them that you could like put into numbers, like
No,
a
but
failed production, or I don't know.
No, but
Maybe there
I
isn't.
like the thought. I think I need to write a longer talk. Yeah.
Hey, I was wondering, like, I'm an engineer, and you said this was like an API for the engineering team, and
What does that mean?
not what does that mean, but more like, so am I supposed to come to my the DevOps team and tell them, look, this is how much time this is taking me. I want it to be better. 'Cause is this like
I think so. I think, I know platform engineers spend a lot of time like fielding questions from people that have, I'm one of the engineers that used to go to the platform team and be like, my tests failed. Did you change something in the infrastructure?
Yeah.
Like, I'm sure it's your fault. So I think keeping the services reliable, especially when it's like flaky tests, for example, I mean, it benefits the platform engineers, I think, because it reduces the amount of questions and like fielding.
yeah.
Yeah, I think, if that answers your question.
So would this originate from me, or would you expect them to come
No,
and be like,
I'd expect the platform engineering team to want to do this work, yeah. But as a result of the pain that
Yeah.
engineers feel
of
and
course.
the noise and the,
So it's a
yeah.
conversation. So
Yeah,
I say
I
this is
think
bugging
so.
me, and they say, okay, let's set
Yeah,
some metrics.
it depends
okay.
how your teams are structured.
Yeah, of
and
course.
Yeah,
Thank you.
yeah.
Okay, thank you very much.